你好，今天谢谢大家的光临。Okay. Thank you. Now I would like to start my presentation titled How We Efficiently Manage a Large Number of DB Instances on MySQL Platform. This is the agenda of this session. First, let me introduce myself. I'm Takuya Saiki. The given name is Takuya. The family name is Saiki. I have been working at current company since 2020. I belong to MySQL 1 team. I work as a DBA, managing MySQL instances and developing operation tools. About LY Corporation. LY Corporation was established last year by merging LINE and Yahoo Japan. LINE has 196 million monthly active users, and Yahoo Japan has 55.6 million monthly logged in users. Both services are widely used by many users. Like this, LY Corporation plays the variety of services. Do you guys use any service of this? Oh, thank you. Do you guys? Thank you for using our services. These services run on on-premise cloud platform. LINE and Yahoo Japan each have their own on-premise cloud platforms. And currently, a new integrated cloud platform is under development. This session focuses on MySQL running on the LINE platform. Next, about MySQL on the LINE platform. Even with the LINE cloud platform alone, there are over 12,000 MySQL instances. We, MySQL 1 team, manage these many MySQL instances. In this session, I will introduce two tools we developed to efficiently manage a large number of MySQL instances. The first tool I would like to introduce is MySQL Upgrade Helper MUH. This is a tool for upgrading MySQL instances. On the LINE platform, both MySQL 5.7 and 8.0 are running. But MySQL 5.7 has already reached EOL, so we need to upgrade them. The subterm for MySQL measure or LTS version is 8 years. But it takes a few years from GA to being provided in our platform, and a few more years to migrate from the old version. Therefore, from the start of use to EOL is also 2 to 3 years. And so we need to upgrade over 12,000 instances every 2 to 3 years. Now, regarding how to perform the upgrades, there are two methods, in-place and logical upgrade. In-place upgrade directly upgrades the version of a running MySQL instance. But we didn't adapt this method due to the risk of applications breaking from incompatible changes and not supported for downgrade. Next, logical upgrade is method that data is migrated from old version MySQL instance to new version MySQL instance. In this method, by using replication, pre-checks for data and parameter differences and application behavior are possible. And if any issues occur, rollback is also possible. Therefore, we adapted logical upgrade plus replication method. However, safely upgrading requires many complex tasks like this, and the requirements vary for each cluster. Furthermore, we have to perform these tasks for over 5,000 MySQL database clusters. It is impossible for DBAs to perform this manually, so we needed to automate the migration process That's why we developed MySQL upgrade helper, MUH. MUH is a tool that allows users to safely and easily perform MySQL migrations by themselves through Web UI. This diagram is the architecture of MUH system. To use MUH, at first, user needs to create a target MySQL instance for the migration in advance. Then, user registers the source and target MySQL instances. In MUH, source means the old version MySQL, and target means the new version MySQL. After registration, user can proceed with migration step by step by following the instruction in the Web UI, like this page. Just following the instructions from left to right, user can perform complex migration tasks safely and easily. MUH has some features, and I would like to pick up some of them. The first feature is switchover. Switchover is the step that the writable MySQL instances is switch the source to the target. In our platform, each MySQL database cluster has a unique endpoint for connection. So application needs to switch the endpoint from the source to the target. MUH provides two ways of switchover, offline and online. First, I will explain offline switchover. The diagram on the right side shows the architecture just before the offline switchover. The source and target are synchronized by replication, and the application writes to the source endpoint. At step 1, MUH set read-only equal on source primary node. And then application cannot write to source DB. At step 2, MUH set read-only equal off on target primary. Write to source DB. After that, at step 3, application changes the endpoint from source to the target. And this time, all apps need to be deployed and restarted. In offline switchover, the downtime lasts from steps 1 to 3 until the apps are deployed and restarted. So that may need service maintenance. Next, I will explain online switchover. The architecture before online switchover is the same as in the case of offline switchover. In online switchover, there is prepare phase before the actual switchover. At step 1, MUH registers a DNS record of target endpoint as a CNAME for source endpoint. At step 2, application changes the endpoint from source to the target. And this time, all apps need to be deployed and restarted, but no downtime unlike offline switchover, because both endpoints are directed to source primary node. So application can switch the endpoint in advance with any service impact. Steps 1 and 2 are prepare phase, and at step 3, MUH set read-only equal on source primary, and then application cannot write to source DB. At step 4, MUH set read-only equal off on target primary. At this time, the application still cannot write to the target DB. This is because the target endpoint is CNAME of source endpoint. In the final step 5, MUH reset DN's record of target endpoint. Otherwise, MUH deletes the scene name, registers a record to a record so that the target endpoint points to IP of target primary. This allows the application to write to the target DB through the target endpoint. In online switchover, the downtime lasts from steps 3 to 5 until the DNs can resolve the record information. It is about 10 to 15 seconds, minimizing the service impact during the switchover. I explained about switchover. Next, I will explain the rollback feature. MUH provides rollback feature to switch back the source DB in case any issues occur after switchover. The diagram on the right side shows the architecture after switchover. When rollback is performed, it returns to the architecture shown in the right side, which is the architecture before switchover. To roll back without data loss, backward replication is performed from target DB to source DB in switchover. Backward replication from a higher measure version 8.0 MySQL to a lower measure version 5.7 is not officially supported, so some ingenuity is required. With the default settings, backward replication fails due to issues with default correction of UTF-8 MB4, and the error message like this is output. I will explain why the error occurs. In MySQL, session character set and correction are written to the binary log. The binary log is a log used for replication. It is sent to the replica, and the replica executes the SQL inside the binary log. From version 8.0, the default correction for UTF-8 MB4 has been changed to UTF-8 MB4 0900 AICI. Since it does not exist in version 5.7, this results in the replication error. With the default settings, when sessions commit, the SQL like this is written to the binary log. 255 means the correction ID of UTF-8 MB4 0900 AICI, and the MySQL 5.7 instance that receives this binary log does not recognize correction ID 255. Therefore, replication results in an error. To prevent that, it is needed to use a correction that is also available in MySQL 5.7. For example, I will explain in the case of using UTF-8 MB4 bin. In the myconf file for both MySQL 5.7 and 8.0 includes some settings like this, that content. In the in the myconf file for both versions includes some settings. MyConf file is used for configure MySQL parameters. And in MySQL 8.0, perform this set global init connect SQL. After that, session uses correction UTF-8 MB4 bin and correction ID 46 for UTF-8 MB4 bin is written to the binary log. The MySQL 5.7 instance that receives the binary log and recognizes correction ID 46 as UTF-8 MB4 bin, so the replication succeeds. Okay, I explained about MUH. Next, I will introduce SafeDDL. It is a tool to safely execute DDL. Executed DDL has main risks. DDL, data definition language, is SQL commands used to change the data structure, such as table definitions. We sometimes receive requests from users to execute DDL. However, DDL is likely to cause accidents. For example, disk full due to DDLs with table rebuild. DMLs are weighted due to DDLs with table lock. DDL is weighted by metadata lock, causing subsequent DML or select statements to get stuck. Replication delay caused by long-running DDL, and so on. To safely execute DDL, we developed SafeDDL. SafeDDL has following features. It is available through Web UI and automate pre-checks before execute DDL. SafeDDL has two execution modes, unsafe DDL and safe DDL. Unsafe DDL mode execute raw DDL, and users use this mode for DDL that complete immediately, such as create table. And safe DDL uses online schema migration tools such as PT online schema change or Ghost. In safe DDL mode, DDL is executed using PT online schema change or Ghost. PT online schema change and Ghost are online schema migration tools. They can execute DDLs with table locks and minimize replication delay. PT online schema change supports for key. Ghost allows for flexible throttling. So I will explain how to use SafeDDL. At first, users register the target MySQL instance and the DDL on Web UI. Next, in dry run page, users input the target MySQL endpoint and DDL and select the target schema and DDL type. After push pass button, the table information for the target DDL is displayed like this. After confirmed that the target table and DDL are correct, press the dry run button. Dry run checks whether the state is safe for executing the DDL and whether the DDL itself is safe to DDL execute. For example, is there enough free disk space? Are there any long transactions holding the metadata lock on the target table? Is it a DDL to add a unique key constraint? And so on. If the checks of dry run pass, user can execute the DDL by pressing execute button. After execution starts, user can see the execution commands, logs, like this, and before-after table definitions from the Web UI. That concludes the introduction of MUH and SafeDDL. And here is the summary of this session. They are running over 5,000 clusters and over 12,000 instances of MySQL database in Line Cloud Platform. And we have developed tools like MUH and SafeDDL to efficiently manage a large number of MySQL instances. And finally, our company is currently looking for DBAs in Taiwan. For more details, please visit this URL or scan the QR code. If you are interested, please consider it. I would like to conclude my talk. Thank you for listening. 谢谢。